Hello all, this is Manish here. We will start in 2 minutes. I see 5 attendees and we'll wait for 2 minutes for other attendees to join. Okay, good evening everybody and welcome to you all to Intuit Circles webinar. Let me quickly introduce you all to Intuit Circles. Intuit Circle is an ecosystem to facilitate startups for business growth. Intuit Circle has 4 offerings: connect startups to startup. We have now 2000 plus startups registered with Intuit Circles, and you can leverage other startups for your benefit. Second, support startup by enabling financial fitness using QuickBooks for accounting. Third, providing a platform for building application for small business customers. Intuit has more than 4 million customer base. And lastly, the mentoring session where the startups can benefit by having a webinar on technical, financial, and business topics. With that, let me welcome Elangovan Shanmugam, who is a presenter today on the topic horizontal scaling for millions of customers. Note that you are in mute mode. In case of any question, please type in your question at question tab and it will be answered post session. Over to you, Elangovan.
Thanks, Manish. Hey, everyone. Good evening. This is Elangovan speaking from Mountain View, and I'll walk you guys through especially how Mint actually scaled for with 35 millions of users, and that's the big story behind this whole deck. Let's walk through that. So just to introduce myself, I am a distinguished engineer in Intuit, and I work from a group called the Ecosystem Integration Group. My specialty is about distributed systems, and I have been working in the industry for more than 25 years, developing several different systems within Intuit, and I work for tax documents that we can go get from FI in this case, financial institutions, to offer into our tax softwares. And we have many offerings within Intuit for tax that I support that business. Before coming to this role, I was chief architect for Mint, and that's primarily the talk that I'm going to do here. And we actually developed a software that was deployed in public cloud, actually scaling for 35 million plus registered users, and it is growing. And we bring in like billions of transactions from our side. Any bank transactions it can be, or any loan transactions. It's a various entities that we bring from outside for our Mint customers. And also I developed notification system that is scaling for 10 millions and more on a per day basis. It's an event based notification and so on. And if you want to contact me, I have my contact information on the side here. I have a Twitter handle, and also my LinkedIn is given here. With that, let's jump into the actual content. And so if we are, if we end up in this webinar, if we get out of, concepts like what is I consider as software architecture and why it is going to help developing and scaling for millions of users, and how the microservice is going to be delivered. And again, as I said, I wanted to kind of share some of the secrets and secret sauces that we put in scaling for Mint application. So before we get started, I wanted to anchor ourselves in a conceptual way of thinking about what is software architecture. Way back when I started developing software, I was primarily focusing on this section of something called functional requirement that my product managers create and give it to us, and then we go do software development. And that's kind of puts it in at a place where I write software and I kind of throw it over to somebody else, and who is called operations, and they would start to do it in some other place, and that goes into somewhere on the DevOps and operations and operational excellence and so on. Then suddenly I realized that the software architecture doesn't stop at the functional requirement, and it actually expands it, especially because when you're writing it, you will be probably writing it in a single user mode in your developer environment. It is working for single application, single user application, and suddenly it is not, when you throw that in the internet, there are going to be millions of users hitting that application. So now we need to understand how the business is going to grow. We need to understand what are the security requirements that we need to adopt in the system. What happens is when you are writing the software, suddenly somebody will give you security requirement. Now you're going to put something in the if and else and type of thing. I think in the previous webinar in Intuit, my colleagues shared how we can do the role-based access and access controls and things like that. And those are kind of, think about those are kind of security requirements, right? And so now, how do you really put that in mixture here in the while you are designing the whole system? And that's going to be pretty critical when you are thinking about architecture. It's not just writing the software, it is more than software. It is about the system, about how it is going to be running in the production in a multi-scaled environment where you are not running your software within one system. It is going to be running in multiple machines and multiple data centers and so on. And you need to also connect to the different partners. I have given some of the parties that are involved in this whole system here. You can think about yourself as a developer interacting with the system, and your customers, obviously, you're developing software for your customers. So it's so critical to understand your customer needs. You also need to understand your partner's need, because they may be giving you the data, they may want data from you. Now, how do you really exchange the data securely and with the compliance in place and whatnot? To understand how that interaction will work with our partners. And there are going to be customer care, customer success folks that are going to be helping these customers and our partners. So now, how are we going to facilitate their job easier? And so you need to think about all these things in place when you're writing software. And I think it is one of the learnings for me from my career to really, it really helped me to think while I'm writing software. It changed my way of writing software, and that's critical. And I wanted to call out a few other things about the quality attributes. It's very, very important, especially when you're talking about engineering excellence and operational excellence. And engineering excellence, I call it something like FMEA. FMEA is failure mode effective analysis. When you write software, you need to understand what are the failure points. If there is a failure point, how are you going to mitigate any risk for end users or any of the parties that are involved in the system? And we need to be developing software towards that. Now, if there is say, for example, when you are writing software, you are connecting to a third-party system, and that third-party system takes a long time to respond back. Now, if they are sending the response, taking the latency is too high, now you're going to choke for all your upstream services or upstream users who are using your service, and now you're going to choke everybody else. And so now, how do you really do a disconnect that particular connection, and you continue to work with that? And so you wanted to kind of think about minimizing your blast radius or minimizing your failures in a smaller scale. So you need to think about those type of things. And again, there are several things that you can I have opened up here. You can kind of look through this and then understand how these are going to be impacting your software and your architecture, and you can develop and design based off of that. And again, when we are saying software architecture, it's not just architecture. It's not only technology. There are multiple things involved in it. What I mean by multiple people here, multiple things in here. Think about people, technology, process, and cost. Why we need to think about in the architecture? These are the things that are going to be giving you some inputs about how you want to develop and you want to deliver, how faster, how slower that you want to go, and things of those nature that these are the things that are going to give you an idea, inputs into your design process and help you making some decisions. For example, if you have skill set, there are some Java developers in your organization, and suddenly you wanted to develop something that is going to be used for Python. Now you need to think about how do you really make sure that the talent is created that is going to be useful for your system. And so you need to work through that, and that's why I said it's an input into your design process. And you can think also about process in the way we say, hey, I want to deliver every 2 weeks, and somebody may say, no, I want to deliver as and when I check in the software. And so there's you need to think about how do you really put in your design time architecture. It's not only the runtime architecture, but it's also need to think about design time architecture. Now, how do you put things in place so that you can actually deliver on daily basis or a weekly basis or a bi-weekly basis, and you can define your frequency by which you can deliver. End of it, when you're writing software, you need to think about cost. There are open source, you can go and pick up something from the market, or you can buy software. You can actually build software. Now every time that you are writing software, you can think of that somebody has to go and maintain that software. It's not just you build it and you put it in the production. It is going to run by itself. Somebody has to monitor, somebody has to maintain the code. If there are any extension that you need to write, and so on and so forth. And as you are writing the software, you also need to think about hosting cost, because it's going to be hosted on the internet and some data centers or public cloud. Now you need to understand how that cost is going to be impacting the way that you're going to be designing. And so these are the kind of constraints that you need to think about when you're defining your architecture. And then the second factor that I would say is very, very important, at least the way that I learned in my career, is to define guiding principles. And the guiding principle is going to help you in a way that you can make decisions. Every time when you're going into a place where, hey, I'm not able to make a decision, now you need to create some options and then come back to your principle to understand, hey, do we meet these principles? These are the principles that we set as ourselves to understand, and how do we really go and design these, right? And so we probably have to understand how the system, how much that you have leverage for yourself to design this. By the way, these principles that you and your team is going to define it, and you are obviously going to have some kind of a buy-in from your organization. So that people know that you're developing based on these constraints. And I'll give you some of the examples here. I'm not going to go through every single bit of it. Let's say I want to say zero downtime deployment, and somebody would say, hey, zero downtime deployment means that it is going to be costing so much for us. And why? Because now you have to have, let's say, blue-green deployment. Blue-green deployment, by definition, you're going to have same system running in two environment, meaning that old code is running in one environment. Let's say that is running in 50 different servers. Now you're going to have additional 50 different servers for your new code to be deployed on the site. Now once you're having that, now basically, which means that you're now going to pay cost, right? And so it's a business alignment that you need to have to say, hey, should we invest in zero downtime deployment, or is it okay to take maintenance window? In today's world, every service is expected to have zero downtime deployment. So you want to be able to kind of think about that, and how do you really do work towards that principle. And similarly, I would give you one more thing. I have something called in the number 2, reduce number of FCI. FCI is basically, it's a customer interaction. It's a failed customer interaction is what FCI is, at least the way that we use here. And which basically means what, how do you really build a system that actually impacts the smallest possible vector in your population, in your production. And so what I mean by that, let's say you have millions of customers. If some outage happens, is it going to impact all millions of customers, or is it going to happen 1% of the users, or is it going to be happening for one user? So you need to think about what does that mean, how much should we have to build in your software to facilitate that it should be resilient and working well for your majority of the users. And so you have to think about all these things, and that's where the architecture principle is helpful. By the way, these principles can change by companies and by organizations, and so I'm just giving you a framework so you can define it for yourself how this is going to work for you. And then the another factor that I would always worry about is when we set up principle, we want to know how are we going to be successful against that. And so if I said, hey, I want to have resilient system, again, to give an example, I wanted to have 4 nines of availability. What it means is that I can only have 52 minutes per year at downtime. Some companies solve for 5 nines, some companies solve for 3 nines, 3.5 nines, anywhere between those things, right? And so you define what is your availability metrics or availability goal that you have to have for your service or your business, your product. And so you have to think about that. And so similarly for latency is very critical in the internet today. If your software is slower, people are going to say it's not working for me. And so now how do you again put those SLAs that you're solving for, and that's going to again help you to define your system definitions and how you define your architecture. And addition to this, all the other things that I mentioned about your quality attributes and the blast radius that I talked about, how do you reduce number of, at a given time, at least for Mint, what we said was no more than 10% of the users should be impacted. 10% is 35 million, or even in a daily basis, we get about 1.2 million, 1.5 million users, which is 10% is pretty high in that manner. So you need to think about, is that even a problem that you want to solve? As a business, we said it's okay to have like 10% of user impacted over the smallest time possible. And so you have to think about what does that mean for your architecture, your design. Additionally, what I would add a few things to this is to understand your traffic. And so in Mint, we know every day I have a predictable traffic. Early morning to mid morning in Pacific time, we are going to have high traffic, and then the traffic is going to go slow, and then again picks up later in the evening. So we call that as a mini peak or peak of the day, and terms like that. So it actually helps us to define how do we really do the scaling at that time, or again to control your cost, because if I have the fleet running all day long, I may be losing cost without using them. And so now how do we really define your auto scale policies based on the traffic pattern, based on the time factor, and things of those nature that you can consider in your design. And also we wanted to understand your most used features. That's basically tells me that, hey, this feature cannot go down at all, right? And so I wanted to keep that's the most attractive feature for customers, and everybody when they come into the system, they're going to see that as the first thing, or maybe that's why they're coming in. So you need to understand your behavior, user behavior, system behaviors, and so on. Within that, I talked a little bit about the cost aware when I talked about the traffic pattern. Let's go into a little bit of a deeper understanding of how I defined the technology stack for Mint. And this is how we think about splitting the layers and splitting the components. And so here I have an application layer, and I am also defining this into two different modes. One is the development mode and the other is the runtime mode. Let's look at why I have to do it, because it's all considered within this architecture. As I said, not just a product feature is an architecture, it's everything else is involved in this. And when I'm start talking about application, I also need to think about what kind of content that I'm going to serve in the application, and how do I really design for a content management system, and so on and so forth. So you need to think about that. And once you have application, you're going to be needing to interact with your backend or your database. So you need an API and some kind of services that it defines to help you facilitate all your application features. So when you have microservices, obviously you need to have you would need to think about how do I monitor, how do I instrument the code, so I understand all the factors that we talked about in the previous slide. And then you need to have a data lake or some kind of a data persistence layer where you have data is persisted and it can be used for your analytical purpose and so on. And in the development side, you as an architect, you need to understand what type of source control that you should use, what kind of an analyzer that, maybe you have a static analyzer that actually helps you to analyze your code during the, after you checked in. Is it passing your security vulnerabilities check and whatnot? And so you need to have those things defined. And that's also part of the architecture definitions. And how do I build it? How do I deploy it? What kind of artifact management that I need to do? All these things fall under that architecture. Obviously, you need to have the hosting environment for it. And so this is, in Mint case, we had everything defined, and everything is hosted in obviously in the public cloud, AWS public cloud. We are pretty much Java shop, and the middle layer is where I'm going to be focusing quite a bit today, and we talk more about how that that area scaled for us. And in the API layer, we use Java and REST services, and it's we also have the application layer with the single page application, and in the browser side. I'll go a little bit deeper on those things in the next slide. And now think about application as in like applications are user-facing features, and these applications can be in your mobile or in your web browsers, or it can be mobile browser. Sometimes you can think about your applications running on an IoT device, or many other features. Today in the industry is actually as growing. We are not only talking about SaaS-based businesses, not only applications that are used by end users. There are applications used by your partners, or applications used by your some machines somewhere else, and there are many different things. We want to think about how they are interacting with your application and your backends. And so in the service stack, the microservices area, again, this is where the business logic stays, right? And so this is, this area is the biggest concentration, at least in Mint side. Applications is what users are using, and maybe I did not mention about Mint in this case. Is we are having not only 35 million users, we're also connecting with 27,000 plus FIs, the financial institutions. So we have to scale in both sides, right? It has to be like working. In order for us to give the best experience to the customer, we need the data. And so we need to think about how the data is going to be fetched from the third parties. And so how do we really define that whole layer? We have something called applications platform, and also we have a backend platform, which is an integration platform where we actually go fetch the data. So there is a lot of things go on that area, and I will talk a little bit about those. The data lake, as I said, you need to collect your metrics. So this is very important, and that's what is going to help you to define user behavior, and that actually gives you a lot of insight about when a user is stumbling on systems, are they spending more time on a particular page, many things that you can actually collect and build a lot of insights about customer actions, and that is a key input into our business, our product management, to understand the system, how the system is working, and so on. So it's pretty critical that way. So we need to be able to have that data lake in place. And I'll talk more about the microservices architecture. I think this is where I'm going to give you how our services actually scaled for millions of users. And so your system is not just going to have one service. We call it as a monolithic service, right? And so now we need to split into multiple chunks or multiple pieces. And so in as I given this the descriptions here in microservice strategy. By the way, I have something, a small orientation. This actually mimics the previous slide where we talked about the stacks, and now this kind of tells you where I am talking about, and that's the middle section that I'm talking about. And so here you can, for your business, you can split these services into multiple services, not just 5. It can be 20, it can be 30, hundreds, whatever, however it is split for your business. So you have to think about, how do I really logically group them? In Mint case, what we said is that, here is I given a little bit of a framework here. We said we have features that we need to be able to serve to the customer. From Mint standpoint, we said budgeting is a key feature, and then credit reports is in that order, right? And so we need to kind of think about which is more critical for you to focus more and go and define that solid, or then you have to go build that according to that manner. And so we have splitted budgeting service, credit report service, investment service, goal service, and so on. And so there's quite a bit of things that are happening. And we also have a lot of backend services, which I did not mention here. There are a lot of backend services that actually helps to interact with my integration systems and external partners and so on. So there's a lot of things that are happening, and they can also be running independent of each other. And you need to kind of think about how are they going to be interacting with each other? What kind of an API within the services that you need to create? And is it going to be always by API based, or it can be messaging based? Again, I talked about a little bit here about how you define your intermediary layers. What kind of a database that you need to use in the back end. What type of a brokers in this case, I'm talking about messaging systems. And so you can actually, so what we call it as south and north, right? It's in the north-south traffic, which basically goes through HTTP, and east-west traffic could go to HTTP or it could go to messaging. And so it depends on how they want to interact with each other. So it is up to you to define your business needs, but that's kind of we have an architecture where internal services, they can interact with brokers, and they can throw messages, and depending upon how they want to get back the response. So you can define those SLAs again to work through it. And in today's world, I'm actually moving into something called stream processing, which is also going to work very messaging based, and so event based systems. And so you define based on your needs and your skill sets, and that we talked about in the earlier slides. And so then now you need to think about now splitting this microservices. It actually helps you to define individually scaling your service. So as I said, your budgeting may be used by all the service population in your user base. Whereas credit report, let's say, I said whoever signed up for it. So what that means is that, let's say you have 35 million users registered, and you should be able to provide budgeting feature for all the 35 million users. However, credit report is a special registration required. So there may be a subset of users who are going to be subscribing for credit report. And so now you need to scale budgeting application differently from credit report service. And so now, how is that going to be working for you? Now, how do you define that database separately from your business logic and so on? So now that's why I say, let's say microservices 1 is a budgeting service, microservice 2 could be credit report service. And in this service has a different scaling need, but this service has a different scaling need. And so now, how do you really put your sharding strategy, or how do you really put your partition strategy? And you need to think about those type of things. And this also helps you to define your separation of concerns. What that means is that, for example, as I said, I need to make sure budgeting feature is going to be running 100% of the time, while credit service feature could go here and there. Maybe it can run in like 3.5 nines. It can run for 4 nines, depending upon your SLA again. And so these are the kind of contract that you set with your business, and you work towards that. Okay, and just moving to the next one. So now, knowing that type of thing, let's look at the service in a given service, how the service template look like. Right, I didn't talk about the gateway quite a bit, and so think about any interaction from your application to your service is going to go through a gateway, which basically helps you to define, can I authenticate this request and say this is coming from a valid client? If that layer is pretty critical, because now that's the layer where you're going to take a lot of decisions about, is this application onboarded to this service, and can I authorize that request coming to this service? So there are various activities that are happening within it, but that has to be very, very lightweight, very quick, because you don't want to spend too much time in the gateway. It has to be very fast. And so scaling that layer itself is going to be a complete different challenge. That, that's not kind of talk of this deck, but you have to think about that as well. Once it is coming into the service, now within the service, it is being split into multiple stacks or multiple horizontal layers here. And so they are all running in different boxes per se, right? And so now you can see how the architecture is like scaling and spreading to a bigger scale here. And so now think about, when I'm developing this software, it is running in one of my single development machines, and that's it, right? And so now it may contain its own proxy layer, it may contain its own API layer, it may contain its own business logic layer, it may also have its own database layer, but you are putting it into production, now they are all splitted, right? Now how do we really think about how that's going to be performing in the production? It's not just your function, there are additional things that are added in the production, so you need to think about all these things. So let me walk you through some of these things here. API layer, as I said, it's a REST-based service. In my case, pretty much CRUD operations are handled by that API layer. We expose HTTP methods, and that facilitates your API layer, and then that actually communicates through a broker layer, which basically separates my business logic and API. In my development area, that is not the case. They are all these three are running in one single machine, right? And so now, why do I need to do this? I can also again now scale API layer differently from business logic layer. If this is the business logic layer is the way we are doing a lot of computation, I want to be able to scale that differently from my API layer. API layer may be having a smaller set of machines, while business logic layer may have more set of machines. So you need to think about that. And also, as I said, some of them are interacting with your backend systems, or you're interacting with your partners. There are something that are running as a batch system, so you need to think about how they are actually functioning offline mode, and they are not in the mission critical, or they're not actually interacting with the customer. So which means that you can actually take it a different SLA for that set of servers. And then database layer. Now here is where you're going to be storing the data, and you need to define your access controls, and you probably be better to put it in a different machines, because you may be deploying that in a different subnet altogether. So those are the kind of things that you need to think about. Can you run all these things in a single machine? You can. When you are thinking about going into scaling, you have to think about how do you really deploy them, or how do you really create those artifacts differently. And again, I gave some of the suggestions here. They are just suggestions. It depends on somebody. Based on your skill set, your team skill set. You can define whatever the things are required here. And then in our case, we do use Redis as a caching. We use MySQL as a database RDS. And as I said earlier, it's a Java shop, so we have a lot of Java related code in our packets. So now let's look at a little bit more further here, how this is, as I said, running in the production, right? And so now we are talking about network, and why we need to understand this. These are going to add additional latency to your request, and then it is actually going to impact your customer interactions. So now you need to understand how this is going to be deployed, and what kind of things that you should be able to influence in your teams. And so in my case here, I have a user coming in, and they are probably using some kind of application. It can be a web application, it can be a mobile application. And when the request coming in, I'm not even talking about my gateway layer here. Think of that gateway layer is passing through and everything. So there's a bunch of code that is actually working through this area. Eventually that it hits my load balancer. and then it hits into my proxy layer, and I'll talk about proxy layer a little bit, why that is required. I'll come to that part. And then API layer, broker layer, business logic layer, and eventually it goes to database. As I said, now each ones will add network latency. So you need to be understanding that how much latency that is being added because of the network hop. And so you need to think about those type of things when you're designing your system. Now look at here, why now. So as I said, it can be scaled. It can be scaled differently for different layer, and so you need to think about that scaling strategy. You may have just one API machine that means it's a single point of failure. If that crashes, now you need to worry about how do I bring the next machine. So you have to think about that. Like I need to have redundancy, and so you're going to have that. And so one of the principles that I said, avoid single point of failures. So now a broker could become that single point of failure, but now we have a secondary broker, which is the master slave broker, and that actually replicates the messages in both. In case of one crashes, the other one become the master, and then it will bring back the newer instance. So typically both going down is pretty unusual. So you have a redundancy here, so that actually helps you to define. In Mint case, we are using broker. As I said here, it is basically a RMI over JMS type of model, not necessarily asynchronous model. This is synchronously happening because users are waiting for the response back. So when the requests come into here, it actually goes in the broker layer to the business logic layer, and then fetches the data, computes it in the business logic layer, and then comes back to the same messaging to the same instance that originated the request in the API layer, and then response back. And today we are experimenting more to think about, hey, how do we really do the broker layer instead of ActiveMQ? How do you go to Kafka, or even in the Tomcat layer, which is API layer, which is Tomcat? Now we are thinking about how do you go to, let's say, Vertex kind of infrastructure. And there are several things that you can pick and choose according to your business needs. So if I design today, I may be going into modern, NIO based kind of thing, HTTP2 based kind of things, and so it depends on your business needs. You can control that. So let's think about how am I deploying this in production. So it's pretty interesting because now you need to scale horizontally scale, right? You just saw one stack, which is a service stack, and now we are going to think about how that stack is deployed horizontally. So I have, again, we said it's deployed in AWS. And so obviously it's fronted by Elastic Load Balancer, is the ELB, and that's getting into the system. And so there are several security policies that is put in there. Even above that layer, there's several security logic put in there. And then now you have them deployed in availability zone. Now it is kind of horizontally scaling with multiple stacks, right? And so it's here I have the whole thing that you saw in the previous slide. Let me make sure that it's kind of caught their attention. So this whole thing is going to be horizontally deployed for multiple users. Let me go back here. Sorry. And so now I'm talking about in one availability zone how they are splitted, right? And so now you have stack 1, stack 2, stack 3, stack 4, and they are all deployed here. Now, what is this routing and stack picking mean? And so when a user coming in, I have a strategy of saying, hey, if I'm the user, my data is going to be somewhere in this stack 1. And so I'll show you something here in the stack 1. Now, how do I really push the user to stack 1? When I'm coming in stateless, right? I don't have any way to figure out this user's data is in S1 stack. And so let's say you ended up in something in the S3 because it's a ELB that's routed to one of the underlying stacks. There are load balancers within it, so you can go to different API machines and so on. Now it went in here, but it understands that that user's data is not in this set of databases, but it's somewhere else. And so I have something called a central stack, which basically has a reference. It's basically this user's data is going to be in S1 versus this user's data is going to be in S2 and so on. And this is a bit of a logic that I built into sharding the databases. And it's the partition strategy is different for different service. So I'm just giving you one of the examples. And so you could do the similar way. How do you want to partition? How do you make the data is closer to the service that you can actually go fetch it rather than hopping through multiple places? And so you based on your SLA again, you may have a latency SLA that actually tells you that how do you design that. And so now that's how now I found gone into S3 and I'm kind of talking to the central stack and find out, hey, where is this user's data? And why central stack is replicated in many of these servers also. So I don't need to go to central and then copy, because the central stack would become a single point of failure. You don't want that. So the data is replicated in all the other places, and that you can make a determination saying that, oh, I need to route it to the S1 stack. So we bounce it back to the proxy layer, and the proxy layer now goes to S1. And that's kind of how in production, in how you want to think about when you are scaling it, now how the users are going to be getting to the right place to get their data. Now let's go into the something here, even more horizontal. So we talked about failure modes and redundancy, and making it available for 4 nines and so on. Now think about how do I make that happen? Now my site is now deployed into 3 different availability zones, right? And so the same stacks are replicated into 3 AZs. Availability zone is known as AZs. So they are deployed into 3 different AZs. And now the servers, for example, when I say stack 1, I don't want to keep stack 1 that uses data only in availability zone, but the same should be available in availability zone 2 as well as AZ3. The reason that is, let's say for whatever reason in AWS there's a network glitch that happened and our power outage happened where availability zone gone down. Now I cannot just go and say, hey, S1 users, your site is down. So what this means is that now that users request will be routed to AZ2 and AZ3, and they will be happy and they will be served, right? And so you have to think about how that actually is going to help in terms of redundancy, as well as making your SLA for availability is taken care. And this can also work as your DR, but DR has a different problem to solve that, and so I'm not touching that here. And now this is kind of helping me with our HA. HA is high availability. Right now, then now think about additional things that you need to worry about. Again, we talked about blast radius, reducing the blast radius in terms of failures. For example, you would want to define what is your partition strategy, how that data is ended up in here for this user. So why do I need to have multiple shards within the stack? And think you have to worry about all these things. Again, it's up to your systems and your requirement. You need to think about, should I have 1 DB or should I have multiple DBs within a stack? And so you have to worry about all the things. So if it is 1 DB, what happens if that 1 DB goes down, or if that 1 DB grows bigger? Now how do I really short them, right? And so you have to worry about some of these constraints or some of these requirements. So by designing this way, it is automatically now expandable. Now, if my more users are coming in, there is more needs to be growing horizontal. Now I can go create S5, right? And then that S5 will have a set of users. And so that's some of the things that you need to think about. How do I really do operational requirements, like things like stack rebalancing? So what does that mean? Stack rebalancing mean? So let's say your S1 is your oldest stack, which basically means users who signed up, like 20 years ago, 10 years ago, or even 5 years ago. And S4 is your newest set of users. Now, typically your user behavior, that's why you need to understand the user behavior, which we talked about earlier. New users may be a lot more active than the old users. Now, just because their old users are inactive, if you're keeping all the data of old users in S1, now what happens is that whole compute tier and the data tier is now used for less number of traffic, and which basically means you're paying more cost for those set of users. Now you should be able to swap these things. So that's what is called stack rebalancing. You should be able to go and say, hey, this database now cannot be in S1. I need to go into S4. And so I want to kind of balance the traffic by saying S4 and S1 will have the similar set of traffic, a similar set of users coming into the systems. And so these are the kind of things that you need to think about defining your architecture. And so you have to worry about those things. Now think about when you are having this type of things, how do I roll out new data models? And how do I make modifications to existing data model, right? And so what that means is, again, we said there's no downtime in your deployment, right? Now you cannot take these machines out. You're going to be upgrading your database versions, and during that time you cannot put your service not available message out to the customers, because that's a bad experience for the customers, and it is going to put your business in risk as well. So think about, how do I deploy that? And so you may want to have redundancy in your data obviously, right? So you want to be able to do the changes on your slave machines or the backup machines, and then you swap the backup to the master and master to the backup, and you deploy those things. And similarly, we talk about canary deployment or blue-green. Why we need to have those? And because again, reducing the blast radius. You don't want to put a maintenance window, so you want to kind of think about how do you make sure that site is up and running for at least some users. You say, for example, I want to go take out deployment for S1, which basically means I'm going to create a second stack for S1, and I'm going to deploy my new code into the new second, green, you use your newer stack, you deploy your code there, and then you route the traffic to the newer stack within it. And so what we normally do is that we keep the old stack and the new stack within it, and so you swap the traffic to slowly throttle them. So we never go to zero to 100%. I'm talking about, let's say I deploy the software in the S1 layer and S1 stack, and you put that software into both stacks, but your router here or the ELB here, you have a logic saying that I'm going to go to green or I'm going to go to blue based upon a traffic knob. And so you can tune them according to your needs. Why do we need to do that? Because your new software might leak some quality issues, some bugs, our memory leaks. So you want to understand how the system is behaving. So you route the traffic slowly and increase the usage later. Once it's all working well, you move everything to 100% to the new stack, and you start deploying it to S2, S3, S4, and so on. So you have to think about, how do you reduce that blast radius? Okay, I want to touch upon a little bit on the application architecture. Again, that's hopefully so far the service architecture, how that is, scalability is considered, how that scalability is achieved, and hopefully I was able to communicate with you guys. And then application architecture. What is application scalability in application architecture? And so now you have to think about, earlier I gave you some of the examples in the current world. It is not only mobile, web applications. In the 10 years ago, the things have changed, and so now you need to worry about multiple platforms like iOS, Android. Also, you need to worry about tablets, wearables, IoT devices. You can think of all these things, but the experiences are different. But now you may need the backend, which is common for all these things. So now you have to think about how you structure that. At the same time, your functional features are going to be also need to be scalable. What that means is that, one of the product manager will be working on budget feature, the other product manager is going to be working on credit score feature, somebody else is going to work on investment feature, and that somebody will come and say, new strategy, hey, I found a new market, I need to expand to the new feature in the offering. So now, do you go and regress the entire thing, or you're going to create, like a micro application or micro that we call it as a plugin, right? And so so what we do here, there's a app shell, which is a kind of a frame where you can now actually put different plugins and different widgets within it that can that can scale by itself. Again, to control, hey, my plugin 2 is having problem, so it just crashes by plugin 2. It is not crashing the entire application, or you can just gradually degrade that feature, and then you can fix it and then release it, or you can apply different strategies in that area. Again, you need to understand your customer base, you need to understand your user usages, you need to think about all these things while you are defining your application scalability. Okay, and so some other things that I given here about what are the different roles that are required, again skill sets that is required, and so on and so forth, and that's kind of it. And now I have the opening up for any Q&A. If you guys have any questions, Manish, how are you doing on time?
We have 10 more minutes to complete this webinar. So yeah, we are good.
Sounds good. So I mean, this is kind of what I wanted to talk, and hopefully this communicates the nature of how we design the scalability, and how we reduce the blast radius, all the principles that we set earlier on, how that worked for us to our advantage, to our customers and our business. So with that, I open up for any questions. Can people type their questions, or how does that work, Manish?
Yeah, you can type the question. So attendees kindly request you to type any question, and then it will be answered. Okay, I see the first question. Hi, Elangovan. Can you explain a bit more on separation between API and business layer and the need to communicate via RMI over JMS/messaging?
Yeah, great question. And so when we originally invented, Mint architecture, the front layer, API layer, was in the external facing. It's kind of the in the front facing. And so what we did was that we we wanted to kind of think about how do I really protect my business logic layer. So the reason that I did that way, business logic layer has a lot of computation needs, and we want to be able to cache things in the distributed caching and whatnot. And so that particular area has a lot of computation need and memory needs, whereas API layer, I don't need to kind of think about that way. API layer is pretty much converting my internal model to a resource model, and that transformation is the only thing that it does. And so our thought process was that, hey, if I have to scale myself, can I just scale the business logic layer and have the minimum for the application layer, again, API layer? Again, as I said, there's a little bit of a legacy nature to this. If I have to define today, we probably combine them into single layer. But it's up to your needs to think about, should we need to split that, or should we combine them in single? And one thing that I can add is that today we are actually going into this event-based models. And so what we typically do is that a lot of asynchronous nature to this API layer that we build. And so what normally we do, we bring in a request from outside, we throw a message to the backend, which is the business logic layer. We respond the thread to the customer or the application and say, you go out and wait for my response to come back to you, right? And so there are multiple strategies that you can do. Again, in HTTP, you have something called 202 response code, which basically gives you an asynchronous way of, call me back when, and I'll tell you whether I'm done with my job or not. So your service may be running little long running query. So which basically means your API need not to be waiting on your front end, right? And so you don't need to hold that thread, but you still need to compute in the back end. So that's another reasons why that layer would be helpful to split it into two. Hope that answers your question.
Any other question?
Okay, excellent. With that, I think I hand it over to Manish.
Thank you, Elangovan, and thank you, participants, for joining the Intuit Circle webinar. It is great to have you. Please write back to us if you have any specific topic to cover. Thank you again. We end the webinar here. Thank you,
Good
Elangovan.
night. Yeah, good night.
Good night.